Yep, we're live. Great. What are we up to? What are we up to? Let's just check everything. Muppet, you can't go there now. Oh, that's working. Oh, that's good. What else do we need? Chat. There's our chat window. Oh my god, it's down here. There it is. Hey, found the chat window. There we go, yeah. 2:42 PM. Right. Let's get to the right window now, as everything looks good. Oh, we're running. What's happening on that screen? Okay. There we go. Radio, what are we up to today? Yeah. Just trying to get something working. Not sure it will. But we'll see. If it works, it works. If it doesn't, it doesn't. And that's not a problem with me. But if it does, and it builds, and you stop purring at me like that, you're not getting food out of me, not yet. Our little Muppet. He's a good one. He's a good one. Let's have a look, see what that does. Right. Will this build? I want to know if there's problems before I say anything. Oh, we have problems. Oh, right, is that all it is? Damn it. I didn't really want widgets in. Oh, of course, yes, it does need widgets in. Alright, that's good. Because that is correct. Fantastic, let's get that one in then. Common. Oh, why did I leave the common file? I left it hanging around at the moment in 3D. There. To core, please, Amber. And it's needed. Ow, 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 ooh, ow, ooh, ow. Muppet, 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 please. That hurts. I don't know, headers. Add existing file. You, please. Thank you. Yep, just that file, please. Right, that's okay, and it's being used in here. Are you? There we go. Control, save. Non-portable path to file. What are you talking about? Oh, you're just being stupid with me. There you go. What is wrong with this? Non-portable path to file. Oh, for God's sake. Amber. Yeah. That's what we're calling this thing. I haven't done all the work on these, so... Is there a fix for this or not? Alt plus return. Ah, stuff it. Don't care. Next. It's correct. It's just whinging at me. Oh, you got hair on you. Oh, that's you. You're right. Oh dear. Do I need all of this? Core memory. Oh, what does that do? And math. Oh no, I don't want those. I was hoping to get past that. Alright. I'll take you out. We'll take you out. See how many errors we get. Oh, damn, I got to rewrite this then. It's in common. Dumbo. ECS CPP. I should include ECS. Yeah, okay. That's why. I'm sure I was... I mean, Muppet, can you move? Please, come on, love. Okay. Thought I would have done all of these. Map is in here. A H file, not a HPP. And that's a capital E. Alright, that should solve a few problems. I haven't been through these, have I? You can tell. Can you tell what I'm doing yet? Alright, there's that thing there. Okay. That's a lot closer than it was. Unused variables. That's better. That's what I wanted to see, but where are the errors? Ah, here we go. Right, memory. You're joking me. Does need it then. Math and memory. I can't do math. Memory. We're using Qt, so I can't use those two. So that's a mem copy. Where's that? Is that just in the standard lib? I'll look it up. I'll look it up. I've got it on my system. Here we go. Source. There. Where's memory? Core. Header file. Oh dear. Oh dear. That's not gonna work. Yikes. Alright. Yeah, math doesn't do much. Thought not. So math can be taken out. The one's memory, isn't it? It's in core memory. Doesn't do much. No, I can't see the memory part. Ah, damn it. I can't see why it's needed. Alright, let's have a look at the file. Memory, it's mem copy. Alright. Fair enough. Mem copy it is. I've got a horrible feeling I might have to write it. Mem copy. Let's have a look at it. C string. Alright. I want this in common, don't I? Yeah, it's missing. Okay. Right, that fixes that problem. That's now a standard component. Where did it go? Come back. That's just std. Okay. What the hell? Oh no! Ah, right. I've written standardizations of this, protections. Why make it so complicated? Why not make things simple? This is awkward. Destination, source, and size. What's wrong with that line now? Memory is not being declared. Oh, right, you just give me the old thing. Right. The way it says math. We've got resizes. And this is resizing of mathmax. Again, isn't that just in the maths library? Again, that should be in common. Do we not have a normal math? Okay, no idea which one we want. Interesting. Very interesting. And that makes you resize on math. That's just a standard thing. Okay, did I make a CPP for that? No. Because it's by platform. Okay, I'm thinking C and Qt at the same time. And the problem with that is it doesn't always work. There we go. Which one are we doing? We are doing resize. I'm looking for resize. Float to float truncations, right? Okay, yeah. Ceilings. Ah, here we go. There's resize. What are you doing to me? Ah, select sign cars. Yeah, how to do it? Yeah. Randoms. Nope, not using them. Ceiling logs. No. Roundup. No. ABS. No. Min max. Here we go. Max quantity. Oh, damn it. Template. Return value. Blah 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 blah. I could just use generic math. It doesn't do anything. It's structure. It's C math, not math. Ah. Where are we? There we go. Common. So it's C math. Alrighty. Just by the way, the code on GitHub at the moment is correct. Just thought I'd let you know. I'll show you that in a second or two. We've got selection going and everything. What I'm trying to do at the moment is get how can you put it? TD man. I guess that's just STD. Component parameter is an array. Components. Not just a small m. How do you get math max? C++ max. Math. C math. There it is. How do we get max? Header CMath declares a set of functions to compute common mathematical operations and transforms. Okay. Where's max? It's here somewhere. Min max. Maximum value function. F max. Alright. Did I just use math.h? And I clicked on CMath. What the hell's going on here? Oh. X anyway. Oops. Alright, that's that one done. Another one here. It was supposed to be a C. It was going to be turned into a C variation on the subject, put it that way. I think that's all of those. Corrections. Good. We're just down to warnings. So it's building. Oh, it's got its unused parameters. That's a cleanup, which I haven't done yet. Good. Right. I'm finished with that. That's done. That's core SL. Right. I will leave it at that for that. Okay, we'll come back to this. This is part of what I'm talking about today. That isn't. That is. And yeah. Oh, right. Where are we up to? At the end of the last video. Oh, got coffee here. I might need that. I'm a little bit tired today, so I do apologise. I've been trying to prepare this video for the last 4 hours. So I hope it helps somebody. If it doesn't, oh well and good, but hey ho, I hope it does. Right, let's load up. Oh, and if you do want to support us, we're over on Twitch at Fraser Blade Sharp. You can subscribe to that channel to support this research I'm doing, which is now looking rather good. Oh, I had to expand that for something else. You can see I was messing around with that. Yes, I know they don't exist anymore. Don't worry about it. I moved them. You're not opening that file now. Bugger off. Oh, for God's sake, can't you just close the window? Crimes. I'm a bit annoyed at this thing today. Right, Amber SL. I mean, those weren't even part of Amber SL. Don't need to do anything. We just need to close you. Doesn't matter. World Builder. Yay! Ah, thank God. Main. There you go. That's the whole of main. We will build first, just in case. Just in case. Not my problem, that's a mock pre-defs. I don't use pre-defs. I don't care about them. Oh no. Redefinitions. Forgot to take it out. I'll have to take that out. Doesn't really matter actually. It's just redefinitions that aren't needed. Yeah, you're okay then, let's go. Well, are you going to let us do this or not? Yay! Loading up. Isn't this system fast? Yes, this is what you get for a potato machine. Well, can't ask for much, can we? Watch it crash on me because of pre-defs. This is the code that's up on GitHub right now. Okay. Alright, click and the mouse disappears. You click on that and you can drag the dice around. If you click somewhere, it just drops the dice and puts it back on there for selection. That's because we haven't got the next bit, so it's all working nicely. As you can see, it also corrects I also auto-corrected it back to looking upwards, so the number 3 is always upwards. There we go, the number 3 is always upwards. Right, we can't place it. That's the problem. Well, it's not a problem. It's more of what I would assume you want rather than anything that I've planned. So I've put this little piece together today for you people and everybody out there about how games are designed. Is that okay? Yeah, games designed? Yeah, good. I'm glad you all agree with me. So, let's take a look. Now I've got through that bit. There we go. Welcome to Amber 3D, the game. Yes, folks, if you remember, this is not actually designing a game, but a game can be designed from it. This is going to be a 3D network. Now, if you think of a 3D game online, that is actually a 3D network already. It's just that the idiots went and made a game out of it. So I'm going to be an idiot, and I'm going to make a game out of mine as well. How's about that? So, how do you make a game? Well, it's very simple. You just follow the steps. Which is, you need a map area, a player, an enemy. You need a render pipeline. Oh, we've got one of those. The motion integration. We haven't actually got that. Collision detection. We've dabbled at that. We called it selection. Collision resolution. We dabbled at that. We dragged it across the screen. And AI interaction. We dabbled with that just by hovering over it and making it spin. But we also made it difficult for ourselves in all of those areas, because none of those areas were automatic. And that's where we get on to the next part. The entity component system. Misused and broken since time immemorial in every way, shape or form by everybody that does it. Because they try and make an entity. Case in point. In Amber STL, if you have a look under entities, you will find a camera entity, for instance. And it will be a class. It will have all the details on how to move and whatever. Okay? You will have something like a color entity, which will have all the details as a class. Again, this time we're taking in a raw model. We're going to hold on a minute. We're storing this rotation X. We're doing that again. Now, but don't we do that in texture entity as well? Oh look, it's exactly the same. Oh look, it looks exactly the same. Oh look, it looks exactly the same. Oh look, it is the same. And that's the point. That is the whole point. What we have is two classes that are exactly the same, and we're about to make a third one exactly the same. We're going to make another one here exactly the same. They're all the same. So what I could call them is class entity 1, 2, 3 and 4. Hold on a minute, that's just a number. Right. It's a unique identification number. So every entity is given a unique identification number. And that's it. An entity is a number. Full stop. That unique identity number will carry components of data. Like, it may have a mesh, a model, that can be used by our 3D system. Then again, it could want to be placed in the world. Some more data might be needed for that. A second lot of data we could have for that. Because not everything wants to be placed in the world. Thirdly, is it active, interactive? Does it have AI? Is it collidable? Can you collide with it? And then we could have a fourth one and a fifth one. Does it make a sound? We haven't even talked about sound. Shh, don't tell anybody. Whisper, there is no sound. And yeah, there you go. And all we do is then have a system which checks through every single entity and every single component on the entities, and if something is relevant at that time, it will run that component or use that data, only if it's relevant. So we can choose to make individual systems. Like, let's think of some. We could create, let's think. A motion control component. A renderable mesh component. Yeah, I've already done that. Utility component, yeah. I'm trying to think of systems that we can make. It's not that easy to think that far ahead, but I'll try. You would make a main system for the movement control system. You would have another main system. You would add to that. You would add the system motion system. Another main system you might add is a special entity. Like a boss creature or a boss system. Rendering pipeline is again a system, deciding on what needs to be rendered, what doesn't, trues and falses and flags and everything. And then of course you might have your boss rendering, which may be different stages of the boss. Interactions, you've got tests. I think that's the main one to start off with, is like collisions and reactions. So you would make each system a class, okay? And you would make each component a class. So you would have components and systems. And each system is designed to look at and use 1, 2, 3, 4 components, 5 components, 6 components, however many there are. Or however many it wants to check or look at. And if it doesn't exist, who cares? Just carry on. Skip that step. And each entity will have just a list of components. What does this mean? It means that we can create and delete entities on the fly. Because all we're doing is we are creating a number, shoving in a load of components, and then letting the systems do their stuff. So there's 2 parts to this that we need to do. We first of all need to work out a system-component relationship for what we want to do, and then we just need to do a UID and create an entity. So an entity is nothing. It isn't really anything. It just holds a list of components. That's a vector. You could use a map. Interesting. We'll see how that goes. I don't think I've got really much more to add to that, have I? No, right, good. Thank God for that. So what I've done is I've gone back to a previous thing that we did on Amberskies. I can't remember where the heck I put it. Don't know which one it is actually. It was in C++. It wasn't in Qt. Did I do it in here? Yeah. I don't think it's in here, but it might be some of it's in here. Yeah, you can see how the render is going. Is that done? No, that's not done by that, no. No, that was how to design, yeah, okay. How you can design one kind of ECS, which I don't like. There's 1, 2 here. Yeah, right. How you do it, yeah. Oh, serve clients, yeah, I remember that. That was a good series, huh? Something that I did ages ago. That's just game programming itself. Then I went on to Qt, OBJs, yeah. I might have done it in the Thinking Club. No, that's just shaders. Yeah, and trying to go live. No, I don't think it's in there. Oh, damn it. Yeah, this is getting towards it. This is all the foundation work that I was doing for it. Damn it, it's in one of these, and I know it is, because I didn't erase it. And what it does is it goes over the ECS system fully. Could have done it in Java. No, I didn't. God, no. I was showing the timing in Java. That's where we're going to get our timing from. Complicated, but it's good. I think it might be in there. Oh well, not to worry. Not to worry, it's in one of those video lists. If you go through them all, you'll see me using all the code from the previous ones to do this one. So this ECS system was done in C++, and it's going to replace this garbage that I've got here. All of these are going to go eventually. Actually, no, they're not. They're going to stay, and they are going to become part of a component. So all of these become parts of a component because they're already numbers. They are already a number, yeah. They're already in a vector. So it fits on top. Right, so that's explained why. But we've also got something else that's very complicated to think about. And I've glossed over it time and again. And it's this one here. Okay, motion integration. Right, we're going to integrate a motion system. That's going to be the critical part. The pipeline's easy. We've already got that. Motion integration is going to be the main headache. Collisions are easy. AI is easy. Motion integration is an awkward one because of the different types of motion integration. that we can do. There are going to be multiple motion tracks, and I'll show you what I mean. Because everybody thinks like, oh, 3D is dead easy. It is, until you get to motion. So, I'll just move. Right. How many are there? You've got first person, which is obvious, should I say, first person, which means you are looking directly out through their eyes. You have a third person, that includes an orbital camera, so that's eyes equals camera. This one is camera orbits avatar, whether it's a ship, a plane, whatever. Not always a person. You've then got the awkward one, the one that I've been accidentally using on you, which is the 2.5. And that is a camera looking there, looking down. At angle. And that uses mouse movement. Mouse movement. Mouse to move. That one is keyboard movement. That's keyboard move. Third person camera is the same as that, so that's easy enough. They share the same ideas. So those two can be grouped together, but this one can't, because this is very, very tricky to do. Because on this last one, what you've got is you've got a 3D plane with all your hills and trees and whatever buildings you got on it. You've got your bloke in the middle, whatever, always in the middle. Okay, and wherever you click your mouse is the direction he will walk in. Think about that one, about the angles. And you've got to calculate all the angles and how to do it. I know exactly how to do that one, so don't worry about it. I think that was the first one I ever did. All of these bring up the last problem. Okay. The one thing I have not ever covered properly anyway. And that is 3D rotation. Yeah. So, what do we rotate around? Equals an axis. Which axis? At any one point in time, there are two axes, or axi. to be precise, as it's strange language. Which acts like? There's two. There is the world. We've already counted that one. We've decided that Y is up. Z is out of the screen. And X goes over here someplace. Okay? Yeah, you're with me? But what about the model? There's world and there's a model. If we have a cube, some description, its x-axis is there, sorry, its y-axis is there, its x-axis comes through the middle here, not across there, but here, and the z-axis can go blooming anywhere. Out there, actually, on that one. Yeah! What happens if you tip the model on its side? Can't draw it on its side, can I? Yes, I can. There we go. Now we've got a bigger problem that I can't draw. Because now the y-axis is down there, the x-axis is coming straight out to us, and where's the z-axis from that one? That was going through that. The z-axis is now, I can't even work it out. Y, X, Z is that way. Yeah. Got it? So we've got two. And that is why, I'll show you what happens if we use the world axis, X and Y. I'll show you. This is what we get, because this is exactly what I'm doing in this integration of rotation. This is using world axis only. Watch the rotation. It's wrong. It rotates one way, and then it curves around and rotates the other way. And that's because the X and Y and Z direction of the cube itself is not being rotated around, and then it would rotate correctly. So you need to rotate properly and then place is the idea. So you rotate, so you place an item, sorry, no, you rotate the item and then you place it. Okay? Now if you rotate it around the world axes, I think we've got it around the world axes at the moment. Yes, we have. Not the model axes. Then this is what happens. It goes wobbly. Really? Thank you, Cortana. Cortana, please close yourself. Lose yourself, okay. Why me? Why Windows? Oh dear. Cortana has decided that my microphone is to be used. And that, yeah, that can be fun. What a key, that's it. Right, so you can now see that there is a problem. As the x-axis of the cube went out of alignment, it was then rotating around the y-axis and the x-axis, alright? But it was like a convoluted axis that it was turning around. I can't even describe it in 2D. The only trouble is, the only way you can describe it is in 4 dimensions, and that's where I'm headed. Okay, we're going to have to use 4 dimensions. What we're going to have to do is fix our universe to a point. Okay, so I'll explain it this way. We'll use 2 dimensions to start off with. So in 2D, if our bloke wants to turn around, he needs a fixed point in a 3rd direction. He needs a Z direction. So in 2D, if you wish to turn around, you need a Z direction, a point to turn around on. The same is true for 3D. Okay? So in 3D, what we have we then have, I can't draw it because it's not straight. It can't be a straight line, or it can't be. There is a point somewhere that is called W. So you get X, Y, Z, and to turn around properly, you need to fix your 3 dimensions to a 4th dimensional point. Then you can turn around. Now, in 2D, that's easy because you have a vec2 position which we can then add a fixed point to, Z. We'll just make it equal to 1. Okay? Oh, equivalent to 1. That just says. I put too many other lines in there somewhere. So, a vec2 position, if you add the Z factor equal to 1, you've got a 3-dimensional turning point. So in 3D, we would have a vec3 position. So we'll just add W, and we'll just make it equivalent to a 1. I'll put the extra line in, because you're supposed to. I don't like the extra line. Right. That is called the homogeneous position. In other words, it's a made-up thing that doesn't really exist. In the 2D world, the Z position does not really exist. In the 3D world, the W position doesn't really exist, but it's a point about which you can rotate. So these 2 numbers become your homo, meaning 1, either way. Genus, meaning locale, a fixed locality. Homogeneous, genus, homogeneous, I suppose it's pronounced, location. And we're going to just fix it at 1. And it's very important that anything that we want to rotate is fixed to that position. Otherwise, nothing will work. And what happens if you add a W? You get something called 4 numbers. Or 4 identification numbers. Yeah, we're going to be doing quaternions. I've got some good news for you. I've got some really good news for you. Normally, I would do the maths and explain it all. Normally. But today, I'm going to be lenient to everybody. And I mean really lenient. I would prefer to do it on this ECS component, but I'm not. What I'm going to do instead is I'm going to be very nice to you, and I'm just going to put Q quart. There it is. And double click on that. And we're going to use this. Because this will do it all for us. Rotation with 3D, 4D. Rotations with matrices of 3x3s. And it's got everything else. Yeah. It even has that in it, which will tell you how far it has rotated as a percentage. That's called lerping. Rotation 2 is very useful for getting your camera to rotate to look at something. As in an orbit around, remember? I just said about the orbit idea on third person. And then it goes into the detailed description of it. So basically a quaternion is a Q vector 4D. But the last number of it is a 1. Constructs an identity quaternion 1, 0, 0, 1, i.e. with a vector 0, 0, 0 and a scalar of 1. So it's the first one it's using, sorry. Scalar x, y, z. So as long as we understand which ones we're using, we're okay. I always get it the wrong way around on this one because in Qt it's the first one, and when I write my own I put it at the end. There you go. I put it that way around, conjugated. Sorry, not conjugated, that's the negative quaternion. So, yeah. This will give us rotation. Alright, so now I've got that. We'll have to write it all, I suppose. But what I'm going to do is I'm not putting this in 3D. What I'm going to do instead is, may as well keep it open on here for now. I'm going to put it in Amber Core. What we're going to do is we're going to build the ECS system up, system by system, literally, and component by component. So we will have something missing here. Oh, that's because it's an empty. Alright, that's fine. I've got a couple of empty folders here already and waiting. And we're going to be doing the components of systems, and then we'll put it all together and we will make ourselves a proper rotation system, movement system, and keyboard, mouse, whatever you want to use. You can use a PS2 controller. We'll do all of that so you can make all your controllers and stuff like that. Just plug them in to the system. And I'll also get rid of all of these damned unused parameters which aren't needed. Or they're actually parameters that are there for use when we do the programming. You'll see. They're there for a reason, put it that way. So it's probably okay being in there. You'll notice that most of them are IDs, handlers, ID, handle, yeah, they are. One of these will be... Yeah, we're also going to need delta time. The last part of the system, ECS, is time. So, whilst we're doing all of that, we have to have in the back of our minds... Ooh, gosh, didn't realise it did that. We're going to have in the back of our mind, going back up to here, a little bit extra, which we have completely ignored. Time. I hate dyslexia. So time equals the time now. Delta time is the time since the last action. And that's all we need. And there we have everything now for a game. Nothing omitted. Nothing scary. Everything's written. What I'm going to do is I'm going to put this ECS system... No, I'm not going to put the ECS system up yet because I haven't completed its integration. It might not integrate and I might have to rewrite it. Yeah, that'll be fun. But I will try and integrate it. So what we're going to have to do is create a program to integrate it with. So we are now going to have a test game. Okay. Where should we put it? We shall place it. We'll find out here, won't we? Open. New. Console application. We now know we can use console applications. We've got a 3D window. We're happy. So we can choose that. We'll call it test game. We're past the testing part of just development. We've got all of that. We've done all of our development except for the time bit, which we have done, but I covered it in Java. For some reason I did it in Java. God knows why. But it doesn't matter. It's all the same language to me. So test game. Yeah, we can do that. Qt program. Yeah. That's okay. Fine. So we'll have that. Next. 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 I'll have that one, not that one. Build directory. Next. That'll do. There we go. We're up and we're running. So what we're going to do now is build that test game up. I will just ask it to open World Builder. Because funnily enough, we've been doing it already. Yeah. So our test game is going to bring two things together. Active project, please. Add existing library. We'll add a library. External. Yeah, we can do that. 1 second. We're not going to add that library just yet. It is Amber 3D. All right. First of all, build. Make sure I've got a recent build of it. Oh God, all those redefines. Sorry. I will take those out. My bad. It's happy? No, it's still building. Oh, damn. It worked. Yeah, force line redefined. Ooh, thank God for that. Core. Build. That's fine. Build, please. That's fine. Test game is going to be set. Don't need you. We're just going to use you for copies. That's okay now. Right. Add library. External. Next. I will browse. I want a 3D library, which is in the build directory. Debug. There we go. And that is without the build and debug. And that last thing. Okay, that's alright. Only bothered about Windows at the moment. I'm not doing a full dynamic static, please. Library, blah. Library inside debug. Release subfolder. Yeah, next. Finish. Okay. Now comes a good bit. Add library. Yeah. Who said you only could add one library? We'll just do Windows again. We'll browse. This time we will go to the core, build, debug. There it is. Open. We'll have you static. Yeah, next. Nope, don't do next. Get rid of that lot there. Yeah, that's good. Next. Finish. Lots and lots of mess all over the place. I don't care. GUI. Core GUI. Okay. Core GUI widgets. I'll go with Core GUI. Let's see how far we get. I'll take you two. I'll take 17. I'll take C11. Ooh, sugar. App bundle, no, don't want it. Main, okay. Done. Alright, can we all close please, because you'll all start opening every time I try and do something. So the main is quite easy. It's basically that. We're not going to do that. We're not going to do that or that. I should do. Make sure everything works. Okay. Oh. Oops. Carry out. Dim dim dum dum. Widgets. Oh well. I tried. Menu system. Undefined reference. Why would that be undefined? Oh, because it's not included. Oh god, yes, we never included it into the profile. It's not in here. None of it's in here. We've got entities, we've got models, we've got textures, we've got everything, but we haven't added the rest of the stuff. Oh, oh, bad, bad, bad blades. Sources, Amber 3D. Oh god, how are we going to do this? Amber 3D. Add existing directory. That one. Have we got maths already? Don't think we have. Maths. Right, okay, we'll just do the lot. Okay. Did it work itself out? What have we got now? Alright. We should have maths up here. Yeah, that's good. We've got all the clamps and everything. Amber. Build. Dooby-dooby-dum-dum. That's better. Only 2 redefinitions this time. We'll take those 2 out. It's a running. Fantastic. It's working. Absolutely fantastic. So yeah, unable to open file. Blah de blah de blah, because we haven't put them over. So what do we need? We need resources. Okay. And we get resources from blah de blah de blah there. Easy to do this. We are going to take it. Where are we taking our resources from? We can take them from Model Converter now, because that's our most up to date. Yeah, that'll do. Don't need to save that. Just go to Qt. Goodbye. Test game. Add existing files. Eek, cancel. Nope. Add existing directory. Okay. Yeah. Fantastic. Oops. Why's that? Who's unable to open the file? OpenGL shader? Yeah. Ah, yes, I remember. Projects. Build directories build. The run directory is test game. Go back to edit, run. Pardon? I did do the right one, didn't I? Test game, yeah. Yeah, run. No, that's fine. Do I have to reload? Test game out here. Okay. Please do it properly this time. Are you done? I think you are done. Resources GLSL Fong Culvert and Frag. Maybe it's not there. And it's right, it's not there. Why? What? I thought I'd just taken this resources out of the other one. Okay. What's going on? What's happened to my resources? World Builder, resources, GLSL. Yeah. Copy. Amberskies. Test game. Paste. Now please get on with it. Good, there's nothing wrong with you anymore. There we go, that's correct. There we go, we've got a little model in the centre, and we've got the world base. So that's all done for us automatically. Very hard to see it because we also have that mystifying fog effect going on to stop us seeing too far. That's done on purpose. But this is also from a long way off, so it's very hard to see bugger all, actually. But it is there, you can see the different shadings. That'd actually make a nice wallpaper. Maybe should have done it in amber. Okay. Yeah, that's working nicely now. Lovely. So we've got the basis of a game already. But, and there's a big but, we now want to be able to build our main game loop. I think we need to start there, get this timing sorted out, this delta time, so that we can tick it, take a tick. Delta time. I think I've gone through delta time before with the gaming club. I think it was with the game club that we did delta times and we explored those. And we just passed it everywhere, all over the place. Well, you won't need to anymore. It'll do it for you by the time I finish with this. And that is where we are headed next. We are headed into test game development. And I might be stopping more in Qt Creator for a bit, rather than, yeah, this. And then I can get rid of a few more of the warnings that we might not need. I think that might be better. Yes, I think I will. Will this upload? What am I on? Dev. Yeah, I'm on dev. Okay. Tools. Git. Setup for test game plus code for ECS, and I added a dice as well, I think. So, did I add a dice? Have I finally added the thing? Yes, I have. Okay, that's good. As long as we got it. Yeah. Commit. And how do I upload that now? I don't use this Git very often. Remote repo. Push. Let's see if it goes. It says it's finished successfully. It says it has. Let's see if you've got it. No, it hasn't done it properly. That's just a chat. There's no debug there. There's a debug there. This is a master branch. Oh, silly me. 1 minute ago, you see, it's already there. It's on dev branch. It's telling me what to do. I'm just ignoring it. If we're looking core under Amber, you now have the ECS code in full. And what we need to do now is explore ways of using it to build up the foundation of our game mechanics. And it's going to be quite interesting because everything now goes into components. All the rules will go into components. And that's why I need it. And I want to introduce it at this stage because we've gone far enough. I think this is probably the best. I mean, we've gone through the beginning testing. We've done Amber 3D. We can write a file like main that. We can write that much and we get a full 3D window. So, you know, there's not really too much wrong with what we're doing, I don't think. All we've got to do now is get control of everything, and this will bring me to the last thing, which is the map. Because remember, on this map area here, the last thing is this, and that will be the code that we will transfer. If you can remember that we made we still got the model converter. So we take a .obj file and we convert it into a .amb file for Amber, so we can use it better, in a better format for us. So we've got a converter. Well, World Builder will do the same, but for a map. So we'll stop we won't stop auto loading the map. We will start auto loading the start point, or the point of where the character is, or should be, at when they log in. So we will be changing it over to a login point rather than just a square, which is what we've got now. And then we'll have to model it. And that means we'll have to be able to place things onto the map and also alter the data. But we need to know what data we need before we can decide how we're going to do the rest of the world builder. What we now need in our test game will tell us what our world builder will have to, it will give us the output. So what we are now going to do is a test game. And that will give world builder can't do it. I am very tired. Sorry, I can't hide my dyslexia today. Okay, I'm back. That will be output. So that world builder will go to there, and that will go into there. But I don't know what I need. And unless you know what you need, you can't supply it. It sounds obvious, but it's true. You need to know what you want to end up with before you can actually start. When we were doing the model converter, I knew what I already needed. I needed a set, well, just the data in arrays, just dumped out of arrays so we can dump them back into arrays for OpenGL. And that made our OpenGL model loader very simplistic and got rid of all of that hard work that we've been putting into loading OBJ models, which is now hidden away in the converter. And as all the world bits and pieces will be hidden away in the world builder, but that will extend into something else later, and we'll talk about that when we get there. So that file can be saved as desktop, and it's Amber game. There we go. So that's my sketchboard for it all. And what we're going to do next is go through this and do it bit by bit. It's going to be good. I think it's going to be quite simple and easy at the end of the day. But all we've got to do is make sure that we keep breaking things down into simplistic things, discarding what we don't need and keeping the good things. And that's all there is to it. There is no special magic to programming a full MMO. There never was, there never will be. It's a doddle. It just takes time, and that's all. And we have started with, wow, look at all of that. We open a window and boink, it's got a world inside it. Yeah, and it's going to continue getting better as we start finding out more and more about what we need. Hopefully that makes sense. I hope this has been instructive, and I hope that if you do want to use that code, feel free. If you want help on how to use that code, that's coming up, because we'll be using it and we'll be making our files. I like that. That all made sense for me today. How long did that take? I'm trying not to take too long on these videos. I haven't even got a counter or a timer up, have I? Nope, I haven't. 2 hours. Wow, we're on the 2 hour mark. So on that note, because I kept it down to that, I wish to thank you all. Any support you want to give, feel free. And if you want to help me out in the design of this, I'm looking for models, simple models, you know, not very complicated ones, you know, block, Lego type ones will be fine. I'm not looking for anything special, so I am looking for models now to convert. And all you do is you make them in Blender, you save them out as a .obj file and use the converter. There we go. Yep, Amber files. In the meantime, I will say farewell, take care, stay safe, and explore.